Hello everybody, I am Sofia Efadidou, a PhD candidate at the Aristotle University of Thessaloniki in Greece, and today I'm going to present you my co-authors and my work, WearMerge, an interoperable framework for self-tracking data integration and standardization. The self-tracking technologies market, ranging from apps to wearable devices, is booming in recent years, with its sales reaching billions of dollars. Evidently, there are multiple players in the game: Apple, Fitbit, Samsung, and Garmin, among others. This variety leads to significant heterogeneity in self-tracking data, since there are no common standards across manufacturers. But why bother with this topic? Well, most of us who are working in the pervasive and ubiquitous computing domain know how beneficial the analysis of self-tracking data can be, both for scientific advancement and ultimately for human good. However, if our analysis is vendor-locked, if I may say, can we really reap all the benefits of all available data that are out there? Let me dissect this question into 4 challenges that motivate our work. Firstly, as a data analyst, you have to understand your data. However, going through tens, if not hundreds of files for each manufacturer is extremely time-consuming. And you know very well that time is a precious thing in research. Secondly, different manufacturers export their data in different formats, may that be CSV, JSON, or XML, and different representation schemas. The simplest example I can give you is naming conventions. For instance, the step count field might be named steps in one manufacturer and step count in another manufacturer. Thirdly, let's say you're an analyst that has access to a pool of users who own a variety of wearable devices and are willing to donate their data for scientific research. There is no user-friendly and free app for you to use to integrate and visualize their data instantly. PTA. Finally, there is no open source library for self-tracking data integration and standardization, limiting its reusability and accessibility. To this end, we have developed WearMerge. WearMerge is an online platform and accompanied API for the integration, standardization, and visualization of heterogeneous self-tracking data. To help you understand your data, we provide open source UML diagrams depicting the representation schemas of all major wearable manufacturers. We also help you integrate data from Xiaomi, Fitbit, Garmin, Apple, Huawei, and Samsung devices and standardize them using the OpenMHealth standard to achieve a common format. To make it easier, we also provide both an online platform and an API to choose from depending on your technical skills and requirements. And we make all this open source so that at any point you can extend it, update it, or adapt it to your own needs. Our architecture is as follows. The user uploads the self-tracking data folders through the data upload form. Then we move to data cleaning and validation asynchronously in the backend. And of course, the most important stage is data integration and transformation to the OpenMHealth standard. Finally, when the transformed output is ready, the user is notified via email to access data and visualizations. We'll explore this pipeline step by step during the demo. Our tech stack includes Vuetify, Chart.js, and Nuxt.js in the front end, and Node.js with Express, MongoDB, Redis for data storage, SendGrid for email communication in the backend. Firstly, let's explore the user side. Here's a demo video for you. Initially, we need the user's email to notify them about the task's progress. Then, the user has to pick the self-tracking data folders manufacturer by manufacturer. While this might be cumbersome, let's say, it is important to ensure that each parent folder corresponds to a single wearable device or user. Here you can see that WearMerge can integrate data from Fitbit, Garmin, Huawei, Samsung, Xiaomi devices, among others. Once the integration and standardization steps are completed in the background, the user is notified by email to download the data and access the basic visualizations. You can see here visualization by gender, age, brand, and weight. All visualizations are interactive so that the user can really get a feeling of their data. They can select or unselect wearables and users, and they can see progress over time. Additionally, instead of having to scour through hundreds of files, all user data is now conveniently exported into few files. Let's wait to download. Here you can see that everything is stored in 9 files corresponding to physical activity, demographics, heart rate, and sleep data. Easy, huh? Now it's up to the analyst to actually get knowledge out of the data. So, what happens in the backend? Well, let's assume that the user uploads 2 CSV files, file 1 and file 2, with a presented format. During the cleaning step, the program verifies the file type, and for CSV files, it also identifies the header row. For instance, while file 2 had the header row in line 2 instead of 1, the program can nevertheless identify the correct header in the output. In the data validation step, we convert all file formats to JSON for easy handling with MongoDB and compatibility with the OpenMHealth standard. We also validate that the JSON formatting is correct. In the integration phase, we first evaluate schematic harmony. This means that for each file, we check the existence of certain entities. For example, here both files contain the timestamp heart rate field. Next, we perform content-based linkage, meaning that we identify entities that refer to the same measured quantity. Here, despite the differences in naming conventions, we can clearly see that both files contain the same piece of information, heart rate. Hence, we use common name for identical fields. Finally, we handle compatibility issues. For instance, in our example, we convert the Unix timestamp into human-readable format. Finally, we convert the integrated data into the OpenMHealth format as seen on the left, which is also our output format from the data transformation and standardization phase. And that was our demo. I hope you found this demo interesting and that WearMerge can somehow be useful for your ongoing research, either for understanding your data or integrating them to accelerate your analysis. I want to point out that our audience is not just within computer science. On the contrary, we believe that WearMerge's intuitive interface can be useful for people outside CS without necessarily having programming skills. Nevertheless, continuous updates and extensions are required for WearMerge to stay relevant within the pervasive and ubiquitous computing ecosystem. Hence, we invite all of you to contribute. And there are a lot of exciting possibilities when it comes to new visualizations and machine learning integrations. So go for it. Here you can see some useful resources and links. Thank you all for your attention. I'm open for questions.